right? I'll assume that uh, you are working as a DBA and you know the basic concepts of so core DB or so database administrative things, so that I will so start from there, and I'll go with the performance tuning, like from the basics to the advanced. Okay, so this is overall. Let me share my screen, just give me a minute. Right. So I don't know, like, if Sharmak already shared the content, and so what we will have to discuss the index part. So this is completely we were thinking that around 32 hours, or 16 uh, classes, but that can extend, so based on our um, based on so our interest and the way that we are moving forward, right? So suppose if you ask more questions, then I'll try to explain, and based on the questions, based on the concepts, then it may go for more than 32 hours as well, right? So that is the overall duration that we were expecting to complete. Right, so weekly 2 days, that is Saturday and Sunday. So we will go with that. And so yeah, so that is the outline, right? So what we will discuss, so we'll discuss every topic in SQL Server performance related, and starting from so SQL architecture, and we'll go internals of so the query optimizer, internals of so SQL Server, uh, I mean, so operating system. So we'll discuss that internals, and along with the troubleshooting scenarios, right? So understand. So SQL performance tuning is more on like how you understand the concepts. If you want to troubleshoot any of the performance issues, you should understand the concept. Then only you should be able to troubleshoot the issue. So what I mean, like, so there will be uh, so theoretical and along with the practical as well, right? So theoretical as in let's say, for example, architecture or memory architecture, or CPU or scheduler or processor. So these are all you will have to understand to so troubleshoot any of the performance issues, right? So that is the reason. So it is a mixing of both theoretical and the practical. So I will show you so the demos and all, then you will understand the concepts and how to troubleshoot the issues, right? So we are not concentrating on a specific issue, right? For example, let's say a query is slow. So we are not concentrating on a specific issue to fix, right? So we are concentrating on the base, right? If the query is slow in any environment or any query, so how you will initiate troubleshooting, right? So here, this class is not for any solution, right? So we are not providing any solution to any particular issue. So we are giving so guiding you to troubleshoot the issue rather than fixing the issue. So troubleshoot the issue. If you start troubleshooting, then you would be able to fix that issue based on your troubleshooting, based on understanding of the issue and concepts, right? So this is completely, we'll share this so index with you if it is not already been shared. Yes, any questions? Right. So if you don't have any question, please request you to put on mute, so that so it will not be disturbed. Right. So what we are going to share, so I'll share, like, so the scripts that we have, so we'll upload to a Git repo, and I will share that so Git location, so that you would be able to access that, and so test on your own, on your machine, or even in the production environment, if you want to execute few queries to get some data, right? So that also can be done, right? So you can execute that those queries. Second thing, so I will so I will go through this PPT, power presentation, like PowerPoint presentation. So I will share this document, this as a document as well, so that you can refer this PowerPoint presentation. Maybe I'll convert this into so PDF or something that I'll share with you guys, so that you can so keep that handy and refer that document, right? So if you have any questions in between the class, you no need to wait till the end and forget, so the question. So you can stop then and there, and you can ask me, so that I'll try to answer. But if that is related to that particular topic that we are talking, right? If it is something different out of topic, maybe that you'll have to ask at the end, so that I will try to answer if that is needed, or I will explain that later point of time during our session, right? Anyone have any questions?
How many do you have? No, now where was the big pot?
Please mute yourself. Mute yourself. If you're not talking, please mute yourself.
I think the host can mute everybody and then unmute yourself.
Yeah. Thank you. Wait it. Okay, cool. Thank you. Yeah. So any questions so far, or anything that you are expecting, or anything you would like to understand before I even start? So today's session, so today or tomorrow, so we will have so we don't think that these are like some kind of demo or something, but we will start performance tuning, so classes from today itself. We'll discuss about the SQL Server architecture today. So that is very core, and so you should know the architecture pretty well, so we will talk SQL Server architecture, and I will explain that, so if you execute any of the queries, right, how that queries, how SQL engine, database engine, execute the queries, right? So what is the flow, and how that how SQL database engine executes and get the result set. So I will explain. So any questions before we start, or anything that you would like to so talk, or you would like to understand?
Nothing from my
Yeah.
end.
Cool. Thank you. Okay, so and so we'll start on time, maybe around so 5 minutes here and there, so but try to join on time, so that we will start and finish on time, because if it is India, it is day starts, but if it is US, it day ends, right? So better, so understand, uh, and try to join on time, so that we'll finish on time. Cool. Right. So we'll start with so SQL Server. So heart of the SQL Server is SQL Server architecture. So we should understand SQL Server architecture first, so that so we'll have a understanding. So what are all things which are involved in the SQL Server, right? So let's say, for example, you have a query slow, right? Just an example, query slow. So if your query is slow, so if you don't know the SQL Server architecture and the components in it, so it would be tough, right? You would not be able to troubleshoot the issue, so in an efficient way, right? So you will troubleshoot here and there, but you don't know where to start and where to end. So we are just, so troubleshooting the issue, but we don't know how to troubleshoot in an efficient way. So we'll talk about the way that we start troubleshooting. All right. So SQL Server, so architecture is the main piece that you should understand. Okay. Let's understand, so what are all components which are involved in the SQL Server architecture. So these are all main components that we have. One is net libraries, right? Network library, and UMS. So we also call it as SQL operating system. You might see that SOS, right? So it is a SQL operating system, and then it is a relational engine. I will talk all these. So just I'm giving components that are main, right? So relational engine, then next one is storage engine. Next, definitely, right? If you need some data, so it will go to the disk, and then it will have that Windows API. right? So this is the main components of the SQL Server architecture, which are which we have, which database engine is designed on. Now, let's say you have any request, right? Any queries from the application. So let's say take any application, as in like not only the, application of application. So you can consider even SSMS, right? So you are opening SSMS or Azure Data Studio. So that also considered as an application, right? So if you don't know, SSMS is, based on the .NET, right? So that Microsoft has created. So you can consider that SSMS as an application also. Anything you have that client in a client which connects to the database engine is an application, right? Either it could be a SQL CMD, or it could be a PowerShell, it could be SSMS or Azure Data Studio, or even from the application front end, right? So application, as in you can consider that anything, right? So Amazon. So if you have that Amazon, so you will have that Amazon.com or Amazon.in. So that is also a front end application in backend which connects to the database and pull the data, right? That is an application. Application has to connect to the SQL Server. So how application will connect to the SQL Server? I'll use Paint, or so Notepad or something to demonstrate, right? So simply I don't want to show the diagram and explain, so I'll try to draw and explain so that you will have that clear understanding that how that works, right? Now let's say this is your database. Right? So if it is your database and this is your, you can consider this is your application, right? So application has to connect to the database to process something, right? So application has to connect to the SQL Server to perform some operations. Either it is a select, or it is any operation that we have in the SQL Server. Select, insert, update, delete, whatever it is, it has to connect to the SQL Server. So application, we will have the some connection string, right? So in the application, you will have the connection string to mention that the database server name, comma, database name, right? So the other parts, like whatever drivers that and all, I'm not bothered about. So we will have the connection string, and it has to connect to the SQL Server and execute some queries, right? So there will be some there will be some like either gap or network or whatever it is, and how these two will be connected, how these two will be communicated from application and SQL Server, how these will be communicated. There is in libraries, network libraries, net libraries, right? So net libraries are something that it connects. Net libraries is something that the application SQL Server is communicating and talk each other. So what are all network libraries that we have in SQL Server, right? So what are all network libraries that we have in SQL Server? One is shared memory. Second, TCP IP. Third, name pipes. So these are all main three network protocols, right? Network library or network protocols that you can consider. That protocol is nothing but, so communication channel between application and the SQL Server. You have three main protocols or libraries which application SQL Server will be communicated with each other, right? Again, as I said, like application can be your SQL SSMS, or application can be anything which connects to the database engine, right? So now these three are supported, right? So whatever, yeah, I'll tell you. So shared memory. What is the shared memory? So why we require a shared memory? So shared memory, the name itself, right? The memo, so it is the shared between application and the SQL Server. Let's take a scenario. So you have a server, Windows machine. I mean, you have a Windows machine or whatever it is, Windows server, right? So you have a SQL server installed on the same computer, right? And you have an application installed on the same server, right? You have both SQL and application is installed on the same machine, right? Then the protocol which used to communicate is shared memory, because this is on the same computer, right? So same location or same computer or same mission, which doesn't require any additional protocols or any other protocols to communicate with, right? These two, if it is within the server or within, so the computer, so then shared memory protocol is used to communicate between the servers. Now let's say the named pipes. So you have so your SQL server resides on one location, I mean one place, and within within a few, I mean within very, so it's short distance, right? So there is no, so far, like within a few kilometers or within a range. So I have another computer, another server, which application is installed. Let's say you can consider a LAN connection, local area network. If you have a local area connection or intranet, and if you want to communicate between the servers, right? So this is not very far. This is just a so few kilometers apart, or two buildings, or even two within it, two data centers within a small region, which LAN communication can be established, or intranet. So this one, SQL is installed and application is installed, and these two can communicate through the named pipes, right? So shared memory, if the server and SQL is if the server and SQL and application is installed on the same server, we use the name shared memory. If it is a less distance, or if it is an intranet communication, then we can use the named pipes, because it is not very far. It is a local area communication. Let's say you have a one data center resides on South Central, let's say, for example, South Central US. So another data center resides on West US, right? So you have a two different data centers or two different regions altogether, and I would like to communicate. So I have a West US application installed in West US and SQL Server installed in South Central US, let's say. Or once a SQL Server installed in India and application is installed on US, South Central or West US, whatever, right? So if you have wide area communication, so it is a wide area network where you will have that network switches, and where you'll have that the cables are connected to a very wider area, right? So if that is the case, we use a TCP IP. TCP IP we use for wide area network, where if you have, so your SQL or database engine installed on one server, whereas application is installed on one region. So either it could be a different region, different site, or different country, doesn't matter. So you have a very far network, like where you want to communicate. So you use a TCP IP protocol to communicate. So this is the one which we majorly use, right? Even if it is a local area network, so we use TCP IP. But the, so the way that we can communicate, it is TCP named pipes and TCP IP also you can communicate, right? So these three are supported within, so within the server. Even within the server you can use TCP IP, and so the wide area network you can use TCP IP, and so named pipes you can use the servers in a local area communication, right? So this is the three protocols which application and SQL server listen on each other, right? Now the interesting part, let's say SQL server is listening on TCP IP protocol, right? So if application using named pipes, okay, so if SQL is enable TCP IP, right? So we can enable so protocol from the configuration manager. If you're interested, I can show you that maybe. Okay, so okay, so I will have to recompile that. That's fine. So I assume that you guys know that, so we have a configuration manager, and from their network library, you can change or you can enable and disable the protocol of your so network protocol. And the interesting part, like if SQL database engine is listening or enable the TCP IP, whereas application is using the named pipes, right? So if this is the case, the connection would not be established. So whatever application is using, so we should have the same TCP, same protocol, network protocol to communicate the so to establish a communication between application and the SQL server. You should have the same network protocol. If you are using TCP IP, and the application also should have to enable, should have to use the TCP IP protocol, right? That is so that is how the communication should establish. That is the network libraries. That is the network libraries. So UMS, earlier versions we used to call as a UMS, user mode scheduler, because we have our own scheduler at the user mode level. We have two. One is kernel mode, second one is user mode. Kernel level, so the system threads or where it is running at the Windows operating system level, whereas user mode, which is at the our user process, which is taking care and running, right? We will talk that UMS detailed in a separate section, because we'll have to explain and understand more in detail, right? But this is also, we call it as a SQL operating system. Okay, whenever you connects, it executes on the so CPU, some CPU, right? So that is what it is, right? So we will have to have UMS to execute the queries that we are triggered, and SQL operating system you will have. Then the important thing is relational engine, right? So relational engine is the main part in the SQL Server architecture, which helps to execute your queries faster, right? So in the relational engine, what we'll have, so we'll have a different components, right? One is parser, the main thing. So second one is query optimizer, right? So these two are main. So ODS that we have, open data source. So this will, what it does, it will get the connection. So you will have that ODS, so open data services from the application, open data sources from the database engine, and it gets the connection, right? So gets the connection from application and pass that to the further relational engine, right? So ODS, open data service sources. So it gets the connection from the database, from the application, which is established, and pass further for further optimization and execution. Let's see what exactly these are. So relational engine, we have something called parser, right? So parser is nothing but just parsing your query, right? It understand whether the query that you are executing is SQL understandable, right? So every application, or so every either like a database system, or every application will have that SQL also, I'll call it as an application. Every application has their own language to understand the to understand, to proceed further. At the same time, SQL also, one second, someone ping here. Okay, so the question is like, which among is more secured, right? So if you're asking the secure connection, so definitely TCP IP is more secure. And nothing said, like, so TCP IP alone will not be secure. You'll have to have some others encryption, so enable, so that your connections will be secured. So just a plain TCP IP will not be secured, your communication. But TCP IP, we widely used protocol. Along with that, you'll have to have some, so encryption technology like SSL, right? So like TLS. So if you have enabled that SSL encryption, right? Secure socket so TLS and SSL communication, I think secure socket library or whatever. So if you have enabled that, so protocol like encryption technology or encryption method, so the communication through the wire, so the data or communication from application to the SQL server and SQL server to the application, that will be encrypted and decrypted at the source and destination level. So just a plain queries will not be secure, right? So there are chances that so unauthorized access can steal your data, right? That is where we have to use that named by we have to use that encryption methods to encrypt the data. Sorry. Cool. So parser, command parser, right? So let's say, for example, I was talking every application will have its own language or own keywords, I would say, to understand and execute the understand and proceed further. SQL also one of the application which has its own keywords to understand whether it is a SQL understandable language or not. SQL understandable language to execute the queries or not, right? So then it will validate the keywords, right? Whatever we are passing, we are so querying whether that is SQL understandable or not. That will validate by the command parser. Sorry, any questions you can ask me? I don't understand what. Okay, fine. So if nothing specific, you can just mention. But if you anything specific that you want to understand, ask, and you can just stop and ask me, because I cannot keep monitoring the charts. Good. The command parser, so it checks the SQL syntaxes or the keywords that we are executing, right? So if any of the keywords which are not understandable by the SQL server, if SQL is not understanding, then the query will be failed, the parsing of the query will be failed, and it will send it to the user stating that the query syntax is incorrect, right? So parser, it will validate the syntax is correct or not. That's it. So it will not do anything. For example, if I consider a query, if I take here, so if I execute select star from test, right? So if I execute select star from test, so it is showing that as a red. And if you see here, invalid object name, the table name is invalid because I don't have a table with name test. But it doesn't mean that it is an issue with the syntax, right? So the parser will not throw an error while parsing this query, because this is not a syntactical error. But if you see that the keywords which are in a different color, and if any of these keywords are so missing, or if you typo these keywords, then you will see a syntactical or parser failure, right? So if you parse, this is the so this is so the so key for parsing the query, right? Control F5, so it will parse the query that you are executing. Sorry, if you just parse this query, it says that command completed successfully, right? So it doesn't matter whether you have a table or not. So if you just parse it, so it will not give an error. For example, so if you just use a different word than the SQL understandable keywords, right? This is from, and you see the color has changed. And if you try to, so parse this query, then it gives an error as incorrect syntax, right? So this is what the parser does. This parser, it checks whether the syntax is correct or not. Then if the syntax is correct, then it will go for further so step to proceed optimization. Next, SQL compiler, so it will go ahead and compile, and we will talk that when we talk the next slide, right? So The next component is the optimizer, right? So once the SQL server once the query is, so once the query syntactical correction, syntactical validation is done, then it will go for query optimization, right? So this parser does another thing is that you have a query and then it will create a query tree, right? Parser will create a query tree as well. Let's say you have a huge tables and columns and all, and to execute the query that has to be normalized. So normalization is nothing but dividing a big query into smaller pieces, dividing into smaller pieces so that the optimization would be faster or easier, right? The parser will create a query tree by dividing the query into multiple pieces. Then it will go for compilations and all. And the query optimizer picks the whatever query tree that is generated or so forwarded by the parser. Query tree will be so validated by the query optimizer, right? So query optimizer, it checks before it is even so going for further optimization and further so the generating a plan and all. It checks whether the same query has executed on the computer earlier, right? So since we restart the SQL instance, these are all memory, right? As soon as you restart the SQL server, these are all will be gone, right? So this part, relational engine and even storage engine, whatever we have, so these are all in the memory, right? So whatever, if you restart the SQL instance, whatever data which is there in the so relational, whatever relational, you will not have any data, but storage engine you will have data where it will be removed if you restart the SQL instance. But yeah, so it optimizer, it checks since we restart the SQL instance, has there any query executed with the similar pattern, with the similar query has ever executed. If the similar query executed, what optimizer does, optimizer check whether that has already a plan available, right? Plan is nothing but it estimates the execution of your query, right? So let's say for example you are constructing a house, right? So you are constructing a house, and if you're constructing way before the even so construction starts, we will have to have a proper planning to so estimate the cost, the so material, and the people needs to be so construct everything, we'll have to estimate, right? So once so architect estimated the so budget, estimated the labor, or estimated the material that is requires, then the plan will be created by the architect, right? So the same thing, even if you are executing a select any queries, then optimizer will have to understand whether if the plan is already exist or not. The same thing, right? Let's say architect. So this architect want to construct a house, and if you want to construct a new house, he will check whether the existing plan can be utilized and construct the same way that he constructed previously, right? So let's say he want to construct a house, and we'll check like whether the same model or same so pattern that he constructed earlier and he has a plan saved earlier, right? So if that is the case, it is wasting so spending time on creating a new plan, right? Instead he can use the existing plan to construct the house. The same thing, so with the SQL optimizer. So SQL optimizer will check whether the plan is already available to reuse. If the plan is available, then it will take the plan, right? So for the same query, similar query, if the plan is available, then the plan will be utilized by the optimizer and it will go further. If plan is not available, right? If the plan is not available, then optimizer will go for further optimization and execute the query, right? So further optimization as in it will validate, right? So optimizer will validate whether it is a small enough query or not. All right, small query as in like you don't have any optimization is required. Let's say it is a simple select query. Let's say, for example, simple select statement which doesn't have any so huge indexes or where clause, nothing. You don't have anything. It's just say executing select query. It doesn't require optimization, right? So for example, you are executing a select statement and it doesn't have any join condition, right? Or it doesn't have any huge parameters and all. It is just simple select query. Then we consider, or SQL optimizer consider this query as a trivial plan, trivial execution. So it doesn't require any further optimization to execute your query, right? It's a simple plan. So it doesn't require any doesn't waste time on spending time on optimization. So it will not go ahead and optimize the query. It will just consider as a trivial plan. Then it will stop further optimization. So I'll show you. So don't worry, like what I am showing, like execution plans and all, we will talk in detail. So I just wanted to show you how the trivial, so how optimizer and takes that as a trivial, right? For example, you are executing simple select statement, select star from, you can consider person dot person, right? So if you're executing, I'm just capturing that execution plan of the query, but don't worry what we are talking, what we are capturing here, right? It is just, so whatever you have it here. And if you see here, the XML plan of the query, statement optimization level, right? It considered as a trivial and it is not going for further optimization. But if you have a huge table, you huge indexes, or you have a huge joins, or so huge where clause or predicates and all, then it will go for further optimization.
Can I ask a question here?
Yes.
Please, can you show us again how you open this SML plan?
Sure. Again, so as I said, like this is just to show you, so how the trivial plan looks like, how the keyword, like, so trivial looks like in the XML plan. So you can just right click on the execution plan and go to XML, show execution plan XML.
Oh, thank you.
Sure. Right. So you see here, statement trivial, statement optimization level is trivial, right? So the same way, like if you have a optimization is full, right? So full optimization, as in like it is optimizer actually performs something, then you will see here in place of trivial, you will see that full, right? So this is a fully optimized, right?
Can you please elaborate the distance, like difference of trivial and full?
That's what I said, right? Like full, I'll talk in a bit, but if it is a trivial, it is a simple select statement without having any, so huge parameters or where clause or, so predicates, or you don't have a huge any joins. It is just a simple select statement and executed by the SQL engine. So what I mean, let's say, for example, you're executing a query. And if you're executing a simple select star from table or select name from table, whatever it is, it has to scan the entire table to get the data. If it has to scan, what optimizer can optimize this query? It has to scan, it has to go through that complete table, right? It doesn't require any further optimization to improve the performance. You're just executing the complete table with the select statement, select star from, then you cannot optimize this because we are not using any proper where clause or in a where clause or even, so the joins and all. So this is just a simple select statement and it just picks up whatever plan which is available and it is, so go ahead and execute that. Suppose if your table has that index, then it will scan that complete table using the index. If the table doesn't have an index, it will scan the complete table, right? That is what we call it as a table scan. For that, we cannot optimize, or SQL Server cannot optimize further. If you're executing this, either it has to go through that scan of the index or table. So what optimizer can improve the performance by doing this? You cannot use that seek, right? If you're executing a simple select statement in this way. So that is what trivial is. Trivial is simple statement which SQL Server optimizer doesn't even consider and proceed further optimization to generate a plan. It is just pick that plan and proceed with that, right? So to optimizer to generate a plan or create a plan, so that requires some amount of time, right? So instead of wasting so some time to generate to optimize the trivial execution query, instead of that, so it is just so considered as a trivial because it cannot be further optimized, and it is just optimizer go ahead and execute the query, or go ahead and create a plan for that execution. That is a trivial. Now, let's say it is not a trivial, right? So the query is not trivial. The query we have around huge joins, operator joins, functions, and all that we are using. If that is the case, optimizer will go ahead and optimize in multiple phases. The optimizer will go ahead and check multiple phases of the execution, phases to generate a plan, right? So multiple phases, right? So in the first phase, or phase 0, we call it as, in the first phase, it checks whether the query, so it's a simple enough to get the execution or not. If it is not simple, then it will use that, so the indexes, whatever we have in, so on the table, right? So we will talk that, and it checks that, like in the phase 0, it checks what are all columns that I am using, what are all, so schema that we are calling, and what are all tables that we are joining. So it gathers that information, and the next phase, right? So it will check if it can be generated or the plan already exists to proceed further. If the query is already, if the similar query already executed earlier or not. If the similar query executed, then it picks up the plan and go ahead and execute. In the next phase, right? So phase 2, I would say, it checks whether this query requires any indexes, or whether this query has any indexes, this tables has any indexes which can be utilized, right? It will validate whether the indexes are available, indexes can be utilized, and the statistics, we will talk that more details, but just understand. So statistics, we have whether the statistics are so utilized to execute the plan, right? So these are all things that it will validate and calculates to generate a plan. So it takes that index or statistics, whatever we have. Then the next phase, it will check whether the cost of the execution, the cost, right? The total cost of the execution is more than what we defined for parallelism, right? So we have something called parallelism. We will talk in detail. In this case, like, understand, parallelism is nothing but query running using multiple CPUs or multiple threads, right? So one query executes parallelly by multiple threads on multiple CPUs, right? So we will talk that, don't worry, and about the keywords. So just understand the full optimization of the query. First, it will check whether the plan is already exist or not. If the plan is not exist, then it will check if any indexes can be utilized to generate a query plan, or to so proceed further of the further execution. And if it does find, or if it is utilized that index and statistics, then it will check if the cost of the execution, let's say I'm executing a select statement, and you see here the cost. Right, we will talk that later, don't worry about it. Estimated CPU cost, or estimated subtree cost, you can consider this, right? So it checks that whether the cost of that execution is is more than what we defined for parallelism, right? Then it understand that, okay, cost is more than what we defined for parallelism, then go for parallel execution. Then the query will start so using that parallelism, right? So that are all optimizer will check and will proceed with further optimization and generate a plan of this query, right? Query optimizer, it gets the plan, it gets the, so query tree from the parser, and it checks if the existing plan is already available or not. If the plan is available, it takes and proceed with execution. If plan doesn't have, if we don't have a existing plan, then query optimizer will go ahead and generate a new plan for the query. If it is a trivial query, if it is a simple statement which optimizer doesn't require further optimization, then it terminates and considered as it is a trivial plan, then generates a plan of the query. If it is not a trivial query, then it will go for further optimization. In the further optimization, it checks in a different phases, the optimization perform in a different phases, and so see if it can be improved any of the query performance. That phases, it will check whether the index can be utilized, whether the statistics are available, and whether the cost of the execution is more than what we defined for the parallelism, so that it will go ahead and run the query parallelly, right? So that optimizer will validate, and then it generates a query plan, right? So execution plan. This is what architect does, right? Like architect to construct your house, he has to create a plan. The same thing, optimizer, before executing a query, it generates a plan. That is what we call it as a estimated plan. Right? So to construct a house, if you have an estimated plan, so at the end of construction, so the plan, the estimation can go above or even less, right? So that all depends on what you estimated and how much it is actually taking, how, so it actually takes. Either it can be a, so either it is a worker or it can be a budget or amount, whatever it is. So at the time of execution, or at the time of completion of the house, then you will get to know what is the total amount or total, so actual is actual, so measure metrics to complete the house, right? The same thing, optimizer will estimate. That is not actual. So estimate, these are all things before even go for further execution. Then optimizer generates an estimated plan. Right? So optimizer generates an estimated plan. So as soon as it generates a plan, the plan in the future, the same query might be executed. So the plan has to be cached. The plan has to be stored somewhere in the memory so that if the plan can be reutilized. So then optimizer, what it does, it will store the plan in the memory storage engine, plan cache, right? We call it as a plan cache. So plan cache, where we store the execution plan of the query. If your query comes again, if the same query executes, then it will go ahead and pick the plan and go ahead and execute the query, right? So that is what it is, query optimizer. So if query optimizer generates a plan, then the plan will be sent to the query executor, right? So query executor to execute the query. The query executor, if it is executing, it needs some data. Let's say, for example, I'm executing this query. If I execute this query, I need some data. So around, so whatever data that I have, whatever rows I have in the table, I need this data. If I need this data, from where I am getting this? So where this data is stored, right? So this, 1 second. So this data is stored in the data file with, just give a minute. Okay, so normally we store the data in the database in a form of pages, right? So 8 KB pages that we have, and we store the data. So these are all, so pulling from the 8 KB page, right? Not only one 8 KB page. So you will have multiple 8 KB pages. It will be okay. So it will scan the pages or seek the pages to get the result set, right? So these are all data we pull, right? So query, while executing the query, so the query executor requires some data to get the pull the rows or pull the data, right? Then what will happen? Query executor, while so during the execution, it needs data to be data to pull, right? If it needs data, then it will go ahead and connect to the storage engine where we actually store the data. Storage engine, don't so consider this as a your volatile or hard disk. It is a memory within the memory itself, right? This is not actually so volatile storage, or it is not actually your so physical storage that we have. It is a different it is in the memory itself. As soon as you restart the SQL instance, the whatever so data we have in the memory in the storage engine will be removed or will be flushed out, right? So the storage engine. If relational engine, it has that query parser and query optimizer and the query execution, right? So in the query execution, it needs to execute the query. Then it will be connected to the storage engine through OLEDB provider. This is just a provider that it communicates to the relational engine and storage engine, right? So let's say, for example, you have a Java based application and you want to connect to the SQL Server. Then you will have a JDBC. You have a .NET application, you want to connect to the SQL Server. You have a .NET framework or .NET based provider. The same thing within the SQL Server, right? So the relational engine and the storage engine will be communicated using the OLEDB provider. So this is one of the provider that it communicates between relational engine and the storage engine. So in the relational in the storage engine, this we will maintain the actual data of your execution in the form of pages, right? So we will talk that so while talking about the select and all, but in the storage engine, what we will have, so we will have a data cache, right? So in the data cache, we will have the pages, that is 8 KB pages. You'll have a 8 KB pages in the data cache. Whenever you perform any of the operations, right? So whenever you perform any operations, either it is a select, insert, update, delete, whatever DML operation that you are performing, and it has to operate on the data pages, right? So where the data pages exist, physically, these pages exist in the data file, that either your MDF or an LDF file, right? So your sorry, not LDF, your MDF or a secondary data file, that is your NDF file, right? So if you have data available in the disk, right, that is MDF and NDF, so secondary file. And whenever this executor, whenever this requires, the query requires some pages to get the data, then the data, this cannot, so if you keep connecting, if you keep pulling the data from the storage, then it will be a IO intensive, right? So it has to connect to the storage. This is your storage layer, and it has to connect to the, so data file, that is your MDF or secondary data file .ndf, right? If it's keep connecting to the data file and get the data, then it will be an IO bound, IO expensive. So instead, what it will do, SQL Server executor, while executing, so it has to pull the pages from the data file and keep it in the memory for reuse, right? The pages can be reutilized. Reutilize is nothing but, so you might need the same pages to be accessed to get the result set, right? So that those pages will be stored in the storage engine. That is one of the part is data cache. So it will be stored. So once the pages are available, then query executor will pull the data and get the result set for your queries, right? That is the storage engine. And the components, like we will talk in detail, like, so next slide, right? So these are the components. Net library, user mode scheduler, that is your SQL OS, relational engine where it actually performs some parsing or compilation, optimization, and query execution. During the execution, you need data, right? Or you want to modify something. So if that is the case, it will go ahead and connect to the storage engine and perform the operations, right? The storage engine and do any modifications. It will be performed, it will be modified the pages, or it needs just a data. So if it needs to pull the data, then it will be access the data pages, and it will perform the operation that we require. Finally, the IO manager and the Windows, Windows API. This is at the lower level of your, server, right? A lower level of architecture. This is not part of SQL architecture, but it is, you need some data to be pulled. That data will be pulled by IO manager, connected to the storage and get the data. This is the operating system where we have that storage and all lower level, concepts, right? Now, let's go ahead and understand more in details, right? So how that works, and so what are our components, and how actually, so the components if we put together all together, right? So let's consider you're executing a simple select statement, or you're executing a select statement. It doesn't matter either it is simple or full optimized select query. There are, I'll consider this as a two things. One is select. Second one is any of the modifications like insert, update, delete. So all work in the same way, and select work in the same way. Select work in a little different, but everything is same, right? So you will have a select, and you'll have any modifications, right? Insert, update, delete. Let's understand how select works to execute and pull the data. So I'm executing a select query, and I just wanted to understand how we get the data. Right. So I was talking the network libraries. This is your application where it resides on a different computer, different location, whatever it is. In the application, you will have a network interface libraries, right? Network libraries. You have a network libraries. That is what I was talking, right? You will have to have a same network library on the source and the destination, right? So you have a TCP IP at the SQL. So application SQL server and application also, you should have the same TCP IP protocol, to communicate and get the result set. Now, so application and SQL server connects, right? So through the TCP IP protocol. Now, in the application, you're executing a select statement. So you're executing a select statement from the application. How it is a TCP network communication, right? How network layer understand there is a SQL command, and I'll have to pass it to the SQL server, right? So there is a network involved in between. It doesn't understand the SQL language. So it just, so it is not a SQL layer, right? It is just a network layer. It has to understand its own language. So I was talking earlier, every application should have its own language to understand. So network also, it should understand whatever we are sending. So that understandable language is the network packets. That is your TDS, tabular data stream. So we call it as a tabular data stream. So which the data, whatever we are sending from the source to the destination, will be wrapped, right, into a one or multiple network packets, and it will be sent it to the SQL server to execute through the network, right? So it can be either from application to the SQL server, or even from the SQL server if you are sending the result set to the application. So that result set will be sent to the application by TDS packets, right? So TDS packet is a, so smallest unit. It will send from one location to another location, or from source to the destination through a network channel or network wire, right? This TDS packet. how that packet is defined, like how soon you will send that, so to the SQL Server or application. There is a size involved, right? If the packet size is 4 KB, I think 4096, whatever it is, 4 KB packet size. So how soon it sends and transfer the packet? If the packet is full, let's say the packet is full of 4 KB, then it will send to the source and destination, source or destination, or you're executing some query, you're executing some small query or whatever it is. And if the query is completed and the result set is fit into this 4 KB, right? Let's say, for example, the query completed and result set is 1 KB and the commit happened, the completed query, then the packet will be sent to the destination or packet will be sent to the source, right? Two things, when this network packet will be sent: one, the query that you're executing is completed. So in that case, it will not validate whether the 4 KB complete packet is full or not. It will send to the source or destination. Or if the query is huge or a large query and it is not fit into a 4 KB, then if the 4 KB size is full, then it will be sent to the destination. That is how that works, right? We know where how to check that network packet size is your sp_configure, right? sp_configure, and this is the advanced option, and you'll have to enable that advanced so advanced option to get the data. Okay, so network right, see here, network packet size. So you have, it is in bytes, and this is the so minimum, and this is the configured value. This is the default one is 4 KB, 4096 bytes, right? So this size, as soon as it is full, then it will be sent to the other source or destination, right? So now the select query that you are executing. Okay, so select query that you are executing. Let's say the select statement is select star from test. If you're executing the select query, right? So then the select query is further divided into multiple one or multiple TDS packets, right? Tabular data stream packets. Once that is divided, and it will be sent to the SQL Server Network Interface library. First, before even sending to this, so TDS packet, what it network packets, what it will does at the server client level network interface, it will wrap this, right? Wrap this select statement into multiple TDS packets. It will just wrap that, and it will be created multiple TDS packets, one or multiple TDS packets. Wrapping is nothing but based on in this TDS package, you will have that, so what query that you are executing, what are the data types that we are using, so what columns that we need, we are, so we require to get the result set. So you will have everything you require to get the execution, right? So you will have the TDS packet and it will be sent. So in the client server network interface library, the query will be wrapped and converted into a TDS packets, and the TDS packets will be sent to the SQL layer, where it receives by the SQL server level protocol layer. So I was talking SQL level, we have protocol, and the application level also we have this, should have the same protocol, TCP/IP, TCP/IP, named pipe, right? So whatever protocol that you have on the source, so destination also should have the same. Now, TDS packets received by the SQL Server Network Interface library. SQL Server Network Interface. What it does, it unwrap the TDS packets. Whatever TDS packets we received, it will unwrap the TDS packets. Then it will be sending that language event. So language event is nothing but your T-SQL understandable language, whatever T-SQL that we have, select, update, whatever it is, that language event will be sent to the command parser. So I was talking command parser is to validate whether the query syntax is correct or not. That's it. So query command parser, it will check whether the query, the language event that it received by the protocol layer, whether that is SQL understandable or not, whether all the keywords are so matching or not. So that will validate and it will send it back to the application. If it is failed, if the command parser is throwing any error, it will send to the application in the same way, right? So this command parser, once it is identified there is no issue with the syntax, it does other thing, right? So once this is done, it will validate and it doesn't find any issues with the so syntax, then it will do a query binding. So what we call it as algebraizing. So algebraizing, where it will bind the schema, right? It will validate whether the schema of the table is defined or not. For example, if I execute this, select star from person, select star from person.person, right? So if you, it looks similar, but these are two different queries and you will see a different result set as well. Because if you don't define schema is a logical container which represents your data, it doesn't have schema. If it doesn't have the schema, it consider by default, the database engine is considered as a DBO schema. If you have this way, then it is a person schema, right? These are two different queries or different tables altogether, right? Because if you don't specify a schema, it considered as a DBO. If you specify a schema while executing your table, along with your table, it is defining a schema, right? It is a different table. So query command parser, it will validate that schema binding. It will check what are all columns and tables which are involved, whether the table is bound to a specific schema or not. It will validate and proceed further. And once it is validated, it creates a query tree. The query command parser generates a query tree. So query tree is nothing but your normalization of the query. Let's say you have a huge query. So that query has to be normalized. Normalization we know, right? So like the dividing a query into multiple pieces so that optimization would be much more faster to generate a plan and execute the query. So if you have a huge query with multiple tables, multiple joins, and the query parser will generate a tree, which tables that I have, and what are all columns which are involved in this table, and what are all keywords that we are using, and what are all predicates that I'm using. So everything is generating as a tree like structure. Like let's consider this is a kind of tree that it has, right? So like this tree, it generates tree like structure, then it will proceed with the further optimization. So it will send it to the query optimizer. So the plan tree or the query tree, it will be sent to the query optimizer. So query optimizer, again, so I was talking earlier, right? So query optimizer checks whether the plan is available in the plan cache or not. This is in the storage engine and in the memory itself. So it checks whether the plan is available in the plan cache or not. If the plan is available, then utilize the same plan and go for execution. If the plan is not available, right, then it will check whether the query is a simple or it is a full optimized query. So if it identifies that it is a simple query, then the optimization will be terminated and considered as a trivial plan, considered a trivial query and generates a trivial execution plan. Then it go ahead and execute the query. Let's say it is not a trivial plan. It needs further optimization. Then it checks whether indexes can be utilized. What are all tables which are involved in this query, and what are all so columns which needs data from, right? And index can be utilized or statistics can be utilized. So or the the query will be improved, or the query performance will be improved by running it in a parallel threads, running with parallel threads, that it will validate and then generates a query plan. So just an example for that. Select start from. So this is just estimated plan. Let's see, it takes a minute or so to get the data. That's fine. I will show you once that is done. Now, so this is the query optimizer. It validates and generates a full optimization. It proceeds with a full optimization and creates an execution plan based on the metrics that we have. Once we have a plan generated, then the plan will be sent to the query executor. So query executor, which executes the query, right? So then query executor needs some data, right? So query executor needs 100 rows to pull the 100 rows to satisfy the query result set. Then it will be connected using the OLEDB provider I was talking. So using OLEDB provider, this is just a provider which it communicates from relational engine and the storage engine. Still running. Okay. OLEDB provider, and it connects to the storage engine. And we have a, so intermediate, a communicator, right? So you need a data. So you need some, so you need to do some modifications, or you need data. So then you will have something called access method. So access method is basically a communicator between your buffer manager, we will talk that, and transactional manager. So whatever you perform, then it is a communicator to proceed further, but it will not do any operations. It is just as a communicator which communicates from relational engine to the storage engine, and within the storage engine there are components, and it is communicator to get the result set. Let's say I'm using a select statement. So then access method receives a request stating that I need some data. Then access method will pass that information to the buffer manager, right? So buffer manager, what it actually does, buffer manager, this is one of the so operator or manager which checks whether this requires 100 pages, 100 rows. So 100 rows, it will check whether, let's say it decides, right, 100 rows, it will be required 10 pages. We know the data we stores in the SQL server in the form of pages, right? So buffer manager identifies it requires 10 pages to satisfy my query. Then buffer manager, what it does, it checks whether the pages are available in the data cache, which is there in the memory or not. Oh, my bad. Sorry. I have not enabled that execution plan to show you that parallel execution. Okay, fine. So this query needs around 10 pages to get 100 rows. If I need 100 rows, then it needs 10 pages to read. So buffer manager, it checks whether the pages are available in the memory or not, right? All the pages available in the memory, that is your data cache or not. If the pages are available in the data cache, then it will read those pages and it will proceed with execution, right? It will read those pages and it will be send the result set to the access method, and the access method will send the result set to the query executor. Query executor will execute and send it to the client using the TDS packets, right? Query executor send that result set to the SQL Server layer, protocol layer, then that will be converted into multiple TDS packets, and that TDS packets will be sent to the application layer. Good. That is if the pages are available. Let's say pages are not available in the memory, right? Whatever you perform, So I was talking, right? Whatever you perform, either it is select, insert, update, whatever you perform lower level, transactional level, and that operates on the database pages. And SQL Server will not directly operate anything on the disk level files. Whatever disk level files, as in whatever pages which is stored in the data file, MDF or NDF, which will not operate. So it has to be available in the memory, that is your data cache, to perform some operation. Let's say, for example, you need 10 pages to read. Those 10 pages, it should be available in the memory. Otherwise, it cannot be performed. Yeah, I mean, so it cannot be operated on the storage level. So it has to be available in the data cache. Let's say pages are not available in the memory. If that is the case, the buffer manager, it connects to the data file and requesting for the pages it needs, right? Requested for pages it required to execute the query. It needs 10 pages. Then these pages will be sent to the buffer manager, and buffer manager will keep those pages back to the memory. That is your data file, that is your data cache, right? So if the pages are not available, then the buffer manager will send a request to the data file, and from data file it pull the pages and keep it in the data cache, right? So then once the pages are available in the data cache, so execution and the other parts are same, right? The pages are available, then so the buffer manager will pull the data and send it to the access method, and from access method it will send to the query executor, and query executor will send that to the protocol layer, and from there it will send it to this application using a TDS packets. Now this is a select query behavior, right? So select query that it performs, right? If you are executing a select statement. Next, we have something called update, right? So if you are doing any modifications, that we will talk, so in a bit. So before that, any questions?
Where this plan catchy will come picture here?
Plan cache, I told you, right? Like if the query optimizer needs plan,
Okay.
query optimizer generates a plan. Before it generates, it connects to it checks if the plan is already available in the memory or not.
Okay.
Yeah.
Means in the buffer manager, we have the buffer pool, and that in the buffer pool, these are the things, right? Plan catch, data catch, right?
Correct.
Or just separate one?
So buffer manager, you will have it is kind of communicator, you can consider that. So it is not that part of so your buffer pool or not. So buffer manager, it is just so internal so kind of clerk or kind of manager, it takes care of that.
Okay.
It takes care of this, right? So this also, it is part of relational engine, not disk. It is part of relational engine and the memory.
Okay.
Here, what is the use of transaction manager and transaction log?
We'll talk in the update. So if it is select query, it will not come into the picture.
Okay.
Yep. That's why I mentioned here, right? Transaction log, and I'll talk that. It is a select statement which doesn't even involve the transaction manager and all. Cool.
Plan cache, I think what it will be the execution plan or what?
Plan cache is execution. Yes, plan cache is the so you can consider it as a container to store the plans, execution plans.
Like SQL handle like this?
Plan handle, yes. Plan handle, execution plans itself, like plan handle.
Okay.
So where is data cache, you will have the data pages, right? The same way like execution plans, the plan handle, you will have that in the plan cache. Yeah,
Okay, I have a question
Yeah,
as well. So from the optimizer checks if we have pre stored plans or not, right? In the plan cache.
Mhm.
And then if it found what's the flow, it goes from plan cache to buffer manager to access method, and then and then query executor. What's the flow from, let's say that we found plan, a pre-stored plan and a plan cache, and then what's the flow going back
Okay.
if it
So
found it?
correct. So if the plan is available, then it will be send it to the query optimizer. So yeah, plan is available, then it will be communicated through the access method and it send it to the query optimizer, query relational engine, and optimizer identifies that the plan. So if it goes back to the relational engine, then it will be going to the query executor to execute the query. So it will not.
Okay, so
hmm.
so it has the plan, and then it went all the way back to the query
Query optimizer.
executor, and then
Query
yeah.
optimizer.
But I can't see the flow. How does it get to the query optimizer? Because there's only one flow out of the optimizer, right?
No, that's what, right? So here, maybe we have not defined like, so the flow that we have, but if the plan is available, right? So query optimizer internally checks whether the plan is available or not. So using the
Right.
access method itself. So your access method, you
Right.
will have, it will connect to the, so the plan cache, and it checks whether the plan is available or not. Then it will be send
Right.
it back to the query optimizer, the same plan.
Okay, but the flow is not visible right now, right here in the diagram.
Correct, correct. Flow is not visible.
Okay. Okay.
Yeah.
All right.
Anyway, like, so SQL optimizer, it internally checks, like there are few other checks also, SQL optimizer, and it checks like, so the plan is available or not. So that is internally takes care. That is the reason I have not mentioned, I mean, we don't have that, the flow here, right? So the plan, how
Right.
the plan will be transferred, how the plan will be sent to the optimizer.
Right. Okay.
This is just our
Okay.
assumption that the optimizer will check that execute plan cache and check if the plan is available. That internally takes care of that by some other communicator, maybe not through storage engine. So it will check that whether the plan is available in its own internal handle, and it understand that plan is available. Then it will go for further execution.
Right. Okay. Thank you.
So any other questions? Okay, I assume don't have any questions, so we'll forward. We'll go forward. Let's say you are doing some modifications, whatever it is, right? So if you are doing any modifications, insert, update, delete, whatever you consider, the behavior is same. The behavior is same until this piece, right? So what does it mean? So it needs some data, or it has to update, or it has to do some modification. It's sent to the access method. So access method is sent to the buffer manager, and from buffer manager it checks whether the pages are available or not. So whether the pages are available or not, and it pulls the data pages from the it pulls the pages from the data file and keep it in the data cache, right? So until this, that is same. Now it needs to do some modification. Let's say you're updating something. If it needs to update something, let's say you have a update query and it needs to update. So if you are updating, it is a DML operation, right? So let's say, for example, there is some interrupt to the update. If there is an interrupt to the update, then the transaction has to go for rollback. Either anything, like you can consider any DML operation that you are performing, and if you interrupt, so it has to go to the, it has to roll back the transaction. How rollback happens? Right? So rollback has to read through the log file. So I'm not going in internal, like, so how the rollback works, but rollback has to read through from the log file that I have, right? Whatever last checkpoint and all. So it has to recover from the log file, transaction log file, right? It has to recover data from the transaction log file. So whatever modifications we are performing, so you should have that modification details into the transaction log file, right? So that is the reason. If you have any so about so if the transaction is aborted, or if the transaction is killed or anything, it will be rolled back by understanding from where it has to roll back. So it will be rollbacking from the transactional log file. So I will talk few other things. Yeah, first understand the transaction log file. So transaction log, whatever modifications which we are doing. So then after so access method, it reaches to the access method stating that there is some modifications required. Then the immediately it communicates to the transaction manager. So transaction manager will take care of the logging of the transaction into the transactional log file. So transaction manager will help to log the transactions which we perform. Okay, so transaction manager. So we have two components, log manager and log manager. Right, I will talk that log manager, but log manager, it will log the transaction which we are which we are going to perform. It will write into the transaction log file first, even updating the data pages on the memory. Right, that is what we call it as a write ahead logging. So write ahead logging is nothing but writing into the transaction log before even updating the actual data pages. Right, why that is needed? Can anyone tell me why that is needed? Why we will have to write into the transaction log before we update the pages, data pages?
For rollback purpose, or if in case anything happened.
For recovery purpose, data consistency.
Recovery purpose, like, so why we need, first we will have to write into the transaction log file. So after, so writing into the data pages, we can write into the transaction log, right? What is the downside of writing? So I mean, what is the advantage of writing first into the transaction log file than data page?
If something happens, I mean, instance, any damages,
Mhm.
we can get recovery from the log file. Any update?
That
Data
is
file
true.
is nothing but physical file, right? Like a
Disaster-
transaction log file
disaster
is
purpose.
like log file, like it's not it will be after like checkpoint happen, everything will be like removed. It's a temporary thing, right? Data file is nothing but physical file. Basically, waiting to the disk is taking more time, and IO operations is taking more time. That is the reason.
Yes, that is true, right? So why we are writing into the transaction log first? Because let's assume that we are writing into the data file, or we are writing first the data cache or page which is there in the memory. If you're writing this first, right? So if you're writing onto the data pages first, let's say there is a checkpoint happen, and the page will be flushed to the data file. So the page will be flushed to the data file. What if the transaction information is not written on the transaction log file by the time the checkpoint happens? Then you will have a page, I mean, the dirty page is written to the data file, or the page which is not fully committed, or so fully committed transaction page is flushed to the data file. Then you will have a inconsistent data in the database, right?
Like
So that is
asset properties, right?
correct, asset properties.
Basically, to avoid dirty reads.
So to avoid dirty reads, I would say no. But if it is a crash happened and if the data has to be recovered, then it has to be recovered from the transaction log file. Let's say if the transaction log file doesn't have this information, and then the recovery would not happen, or rollback would not happen. Let's say, for example, you have not written to the transaction log file, so directly written to the data cache page. Let's say, for example, data cache, we have a 100, and the flush happens, right? Can anyone tell me, like, what exactly the checkpoint? What is your understanding of checkpoint? Just high level, one line.
Checkpoint, like which other data is is completely processed, that will be irregular intervals, that the data will be flushed into the disk when physically.
Okay, so
which are transactions are committed, that will be it will move from the log file to data file.
Okay, so let's say, for example, I have a I have some update query which runs at 10 o'clock. We start at 10 o'clock, and it is big transaction, and the checkpoint happens in every 1 minute. So this 1 minute, whatever modification performed with this update query, it is not yet committed. So whether that write into these pages write into the data file or no, by checkpoint.
If it is not committed, it will not.
It is not
No.
committed.
Yeah.
All agree or have any other thoughts?
No, it will commit,
No,
but during this recovery
transfer to
phase,
data file.
Sorry, go on.
I'm saying that it will commit, but if it's not committed, like after it will do like a redo phase with this all uncommitted transactions.
Let's say transaction is not
Rollback.
committed. Not committed. I'm talking only the flushing, whether the checkpoint will flush the pages from the data cache to the data file or not.
No, it
No.
will not.
If the transaction is not committed. Okay.
Yeah.
Interesting. Okay. So checkpoint, right? So checkpoint, it checks if the pages are modified, right? So if the pages are modified and mark it as a dirty, then if it is 1 minute or whatever intervals that we have, either automatic or indirect, whatever checkpoint that we have. So if a checkpoint triggers with respect to the transaction is committed or uncommitted, the pages will be flushed to the data file, right? Whether the transaction is committed or uncommitted, with respect to whatever transaction is committed or uncommitted, the pages will be written to the data file. That is where you have a transactional write ahead logging concept comes in, right? If the page is marked as dirty and written to the data file, and if the transaction information is not available in the transaction log file, then the rollback, that is your undo phase, will not happen. So undo is it will scan that whatever transactions which has to be which has to roll back, and it will identify the pages, and then it will roll back the transaction or roll back the modification that we have performed. So to answer that question, checkpoint with respect to whether the transaction is committed or uncommitted, it will be written to the data file. It will flash. It will not wait for the whole transaction to commit. Let's say, for example, let's say you have a open transaction and you forget to commit, and still it is open for 4 days, 5 days. So you cannot, so leave the transaction open, right? So the pages, everything will be copied to the data file, right? So flushing is nothing but copy. That we will talk that checkpoint later. But for now, understand checkpoint is written to the data file with respect to the data is with respect to the transaction is committed or uncommitted. Now, now I want to perform modification. So it will be written to the transaction log file first, so that you will have that information from where it has to, where the transaction is open or where the transaction is modified. The transaction information you will have. Once it is understand the transaction log file is available, once the transaction is available at the transaction log file, then the modification is marked as written to the data cache, data file, a data page. So data page as in like your data page in the memory, not in the disk, right? So once it is written, then it will be updating the database on the data cache. Now, so when this will be written to the transaction log file, so it is keep writing into the transaction log file. So what it will happen, you will have something called log cache in the memory itself, right? So log cache also there is some size around 8 KB or even 64 KB log cache, and it checks whatever modification we perform. So it checks whether the log cache is full or not. The same concept that we were talking about the network packets, right? It checks whether the log cache, the size of the log cache is full. If it is full, it will be writing to the transaction log file. The entire log cache data will be written to the transaction log file. So if, just give me a minute. So if let's say transaction is small enough, right? If you have a small transaction, so if you have a small transaction, if the transaction is committed, right? Let's say, for example, you have a 64 KB log cache. If the transaction is committed within 5 KB, let's say, for example, If it is a 5 KB a small transaction and is committed, then it will be completely written to the transaction log file, right? Likewise, if you have a small data, small transactions, if it is keep committing within 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 the log cache limit, it will keep writing into the transaction log file, right? So transaction log file, writing into the remember, writing into the transaction log file is a synchronous way, right? Whenever you perform any transaction, writing into the transaction log file is a synchronous way, so that it will be committed the transaction once it is written to the transaction log file, right? So transaction log file, the transaction will be written, that will be taken care by the transactional manager. That is, internally you'll have a log manager. And while performing any transaction, it needs some consistency. I mean, we have to maintain some data consistency. How we will maintain the data consistency? By acquiring a certain logs. So lock is either whatever lock it is. For example, let's say you have a modification. If you are updating something, and you will be make sure that no other users are reading the data, then what will happen? It is a kind of dirty read, right? So if you're updating data, and if someone is reading the data, then it is a dirty reads. Let's say, for example, you are updating something. Let's, for example, your salary updating. Second, salary updating from 10,000, let's say, bucks to around, so 20. If you are updating your salary, and if the salary is credited based on this, let's say in between the transaction is not completed and you credited this transaction, then you will not credit the other 10K, right? So this is just an example. Then it has to acquire the lock, or the salary, the bank, or you can consider that even you are updating a row or name from ABC to XYZ, and you are reading data, and you see the stale data. You are getting report of all the employees, and you see a stale data, or that old data, right? You are publishing that data to a end user, whatever it is, like you will see a stale data. So to avoid this dirty reads, we will have to acquire certain logs, right? So if you are doing any modifications, you will have to have a so you'll have to have an exclusive log or update log, it depends. And if you are using any select statement, it will be a shared log. We will talk logs in detail in the next, after so few sessions. But yeah, there will be a logs to acquire, that will be taken care by the log manager within the storage engine transaction manager. So transaction manager will perform the transactions which we are performing. It will have the log manager and the log manager. Log manager will log the transaction information into the transaction log file. Log manager, where it helps to acquire a log to maintain a data consistency, right? That performs. Once that is done, it will be written to the so once it is done, then it will be send it to the access method, stating that the log transaction has been updated in the transaction log file. Then it will be send it to the data cache. The same information will be sent to the data cache for it to update. The data cache will update the data page, whatever we have, and it will be marked as dirty. When that dirty page will be marked as clean, once the page is flushed from the data memory to the data file by checkpoint. So
Can you please tell me what the log cache here, where the log cache will come here?
Log
Even
cache
they say
here
that
in the memory storage engine. So let's say, for example, okay, so you are doing some modifications, some update, whatever, like update, insert, delete, whatever you are doing, whatever we are performing. So you will have a transaction log file here, LDF, and you'll have a storage engine here. So you have a storage engine. This is the memory. I'm talking only, let's consider it is a memory. Okay, so as soon as you done some modifications, that modification will not. So we know write ahead logging, it has to write into the transaction log first before even writing into the data page, right? So before writing into the transaction log file, so you have a batch or you have a transaction which generate some log records. That log records will be stored in the log cache first. That is in the memory. So this log cache, once it is full, let's say for example 64 KB, the size of the log cache, right? So as soon as it is full, then this entire log cache as a buffer, it will be sent to the log file, LDF file, to write into the transaction log file. If it doesn't full, the 64 KB is not full, but the transaction is committed or completed within 8 KB, then this transaction data will be sent, this logs will be, the generated logs will be sent to the LDF file to write into the transaction log file.
Okay, you mean to say the transactions modifications will do in the log manager, and during that log manager, logs will be happen, and the modifications, everything will be stored in the log cache. Correct, right?
Correct.
Once the checkpoint occurs, it will be like it will move to the data cache, like data pages.
That is different story, right? So that is a data cache and it will be flushed to the data cache. But I'm talking about the log file and the log cache, how the data will be flushed.
Okay.
So what is the downside of that? Let's say, for example, what is the downside of so flushing in this way? Anyone, any thought? Any downside of flushing in this way, writing into the log cache and flushing into the whatever, like, so any downside?
Maybe time consuming thing or what?
No, not time consuming. So it is better, right? Like suppose, let's say for example, LDF file is your IO, right? It is on the storage. If you keep writing into that IO's transaction log file, then you will have excessive IO operations and your storage will be busy, right? It is definitely an advantage by just doing this. So what is the disadvantage of this mechanism? So the disadvantage is this. Let's say you have a very small transaction and you just, so keep committing the transaction, keep closing the connections, keep, committing the transaction. If that is the case, as soon as the transaction is committed, I was talking, right, with respect to the size of your log cache, your transaction is committed and it will be flushed to the log file. If you have a huge small transactions, what will happen? It will keep writing into the transactional log file. So then you will have a excessive IO operation. So while writing into the transaction log file, you will see a wait type called write log. So write log, if you see any write log wait types or excessive write log wait types, this is one of the reasons. So you are keep writing into the transactional log file, right? So there is a way we can avoid this writing into the, so small transaction writing into the transactional log file. Starting from 2014, we have something called delayed durability feature. So delayed durability. So what it does, it will delay, we know the acid properties, right? The last one is durability, atomicity, consistency, isolation, and the durability. The last one is durability. So writing into the transaction log file and make sure that everything will be persist if there is a crash also, right? So then we will be delaying that writing into the transaction log file. If you enable that feature, there is only one advantage, but there are other disadvantages as well, I will tell. So delayed durability, what it does, as soon as the transaction is committed, if until and unless this log cache is full, it will not flush. So it will keep holding that info, that transaction, committed transaction data also in the log cache until this is full. Until the 64 KB is full, it will not flush into the transactional log file. So what is the disadvantage of using delayed durability? Let's say, for example, the transaction is committed. Let's say you have 10 transactions which are committed, right? Still there in the transaction log cache because the 64 KB file is not full. What if some restart happen or something, so SQL, something happened, which is not there in the log file? Then the transactions which are committed will not go for, will be lost, right? So that is the another disadvantage. That is the disadvantage using delayed durability. So definitely there is a pros and cons using any of the features, and delayed durability will help reducing the excessive IO by waiting until, so the log cache is full before is writing into the transaction log file. But the downside of using delayed durability is if the SQL is restarted, the data which is there in the memory, that is your log cache, will be flushed out. So you cannot revert or you cannot roll back because the data is not available in the transaction log file. Okay, so that is how the transactional manager and any modifications works. Any questions?
This is for same for insert statement also.
Same for anything, any DML operation, insert, update, delete, anything. Yes.
For insert means it will not check for the data cache because that's a new statement, right? Even though you need to check the data cache, everything.
No, so that's what, right? Like, see, data cache, it will not check first, right? If it is any modification, it will write into the transaction log file. So after writing into the transaction log file, it has to insert into a page, right? So it has to insert into a page. So the way that insert would happen, insert will not happen directly to the data file, right? So then buffer manager, it will check the data file, or it will, so create a new page and it will be placed into the memory to insert the data.
Okay.
The
Buffer
page
manager
might
will
not
allocate a
exist
new
already,
page.
right?
Okay.
Yeah, page
Buffer
might not
page will
exist, but
allocate
new
new
buffer
page.
will be correct. New page will be created and insert into that page.
It will not go to the data cache, everything, right? It will go up on, it will place into the buffer manager, right? Buffer manager will page.
So it will be no, buffer manager is just an so you can consider that a communicator to check whether the page is available or not in the data cache, but whatever pages that will be available in the data cache only.
Buffer pool, okay.
Yeah, buffer pool data cache, yes.
Okay. Thanks for the clarification.
I have a question. So when do final data from like insert, or whether it's from update, insert, or anything goes to the data file?
Mhm.
Because my understanding was like usually like transaction goes straight to for example from app straight to transaction log, and then after that all the process happens, the final data goes to data file.
Mhm.
That was my understanding so far, but you said whether it's committed or not, it goes to the data file, right?
Correct.
So the final, for example, like in the transaction log, once everything is done, everything is committed, where does the transaction log send the data to the data file? And how does that happen? What's the flow? Is there
Mm,
any connection between transaction log and data file?
No, so during the checkpoint, so checkpoint, it also checks if the transactions, if any of the transactions which are, so written to the transaction log file, that information also, it will be flashed to the data file. Let's say, for example, transaction log file, you have, so a transaction open. Let's say, for example, a transaction open at 10 o'clock. 10 a.m. whatever, right? It will write into the transaction log file. Whatever modification that we perform, it will write into the transaction log file. That begin tran or LSN information, LSN number, let's say 100, and it will also have that transaction ID of the transaction which it needs, right? It will have that information. So then it will be updated. Let's say, for example, it is updated 100 to 101 or 110, and that update, it will return to the transaction log file at the time of, so after return to the transaction log file, the data cache or data page also will be updated in the memory from 100 to 101. So this will have the header. The header information will be, let's say, the same LSN number, transaction ID, the page ID, whatever you will have that in the page header. Then once the checkpoint happens, then this page will be sent to the, will be flushed to the data cache. So sorry, data MDF file, let's say disk, this will be flushed to the disk, and even in the disk you will have that updated one, whatever LSN information on the page or page ID. So that information you will have in the data file. Now, so if this is modified again, right? So the same page, let's say the same page is modified again. This is modifying again, then the page will be marked as dirty again. So if this is marked as dirty, again the checkpoint will flush the page and it will be replaced with the existing page that I have in the data file. So if the page is keep writing and it will be marked as dirty, and while flushing by checkpoint, so whatever already existing page is marked as that, sorry, whatever page which is already there in the data file will be replaced with the new page which is marked as dirty. And let's say this is not updating, this page is not updating, and the transactional information is updating this transaction, we are updating a new page altogether. If we are modifying a new page, that page will be updated, and as soon as the transaction is committed, right? So as soon as the transaction is committed, then the transaction is marked as completed, and whatever pages which are there in the memory, that will be flushed to the data file. So it will not touch anything which is already there in the data file. So only the problem when it go for rollback. So if it is rollback, let's say for example, right, so transaction starts at 10 a.m. and if it has to roll back, so if it has to roll back, the page is already available in the data file. Because of checkpoint, the transaction is not committed. If it is committed, there is no issue, right? So if the committed, the data is already available in the data file, and the transaction information also written to the, so the transaction information, the transaction ID will be committed, and that will be marked as transaction committed, and the final checkpoint, that information written to the data file stating that transaction is committed, or so the page is updated. What if the rollback happens? Then it has to identify the page which are updated, right? So that the page has that information in the header, whatever the transaction ID or whatever, so the page ID and all in the data file header, you will have that information. At the same time, in the transaction, individual transaction also, you will have that the transaction ID, the transaction LSN number, and the updated page which it is updated, that information you'll have, and based on that information it will go ahead and scan the pages and revert the changes which are already performed on the data file.
Okay, so we are still talking, so that disk that you're talking about, like is flashing to the disk. So we're talking about the same disk right here on your diagram. If you go back to the diagram.
Okay.
So there's a data file right under transaction log, right?
Data file under transaction log. Okay.
So you said once checkpoints run, it flashes out the data to the committed data to the disk, right?
Mm-hmm.
So the disk means our MDF file, right?
So that information, yeah, correct.
Yeah. So that information is this data file right here.
So it will be if the transaction is committed, that will be there in the transaction log file with the commit LSN. At the same time, if the transaction is committed, whatever committed page. So at the time of commit, so the page is available and that page will be flushed to that places will be flushed to the data file and marking as transaction is committed also. That committed information also will be flushed to the data file.
All right, got it. Thank you.
Is it clear?
Yeah, please, I have a question.
Yeah.
So if begin tran is issued and a commit has not been the commit command has not been issued, so that transaction will still be on the transaction log, right?
Sorry, the transaction
And
should be on.
the transaction log, the transaction is still going to be on transaction log and not committed to data file, right?
Okay.
Now I'm asking, when there's a begin tran, for example, when there's a begin tran, there's supposed to be a commit, right?
Uh-huh.
Okay. So when there's a begin tran, that means and there's no commit. Is it that data is present on the transaction log and not on the data file, right?
Transaction log on not on data file. That's what the misconception, right? So if you begin the transaction,
Yes.
if you begin and you have not committed, so you are doing some modification or so whatever it is, and you have not committed, right? If that is the case, right? So the modifications, the pages will be modified on the memory, and the checkpoint happens every interval, like 1 minute or whatever interval that we have. The checkpoint happens, and the transaction, whether with respect to whether the transaction is committed or uncommitted, the pages will be available in the data file.
Okay.
So that
helps,
right? So that helps. Let's say, for example, let's take a scenario, right? So let's say, for example, I have so 100 or so I have 10,000 pages, let's say, for example, and you are using a begin tran, and you have not committed, and there are 10,000 pages are updated with that so whatever huge transaction. So let's say if all these 10,000 pages are dirty at the same time, and the pages are not flushed to the data file, and you're keep writing into you're keep modifying something, and you have not committed for a day or two or whatever, like so if you're keep writing into the data file, I mean data cache, if you keep so modifying pages, then all will be marked as dirty. Then once if you commit, the transaction is committed, then only if you want to write at the time of commit, just assume these many pages writing into the data file is tedious, right? So you will have to keep writing into the data file, so whatever pages that are there in the data file, that are there in the data cache. So that is the reason, to avoid an excessive IO operation. So it will be flushed periodically, check if there is a modifications, and it periodically flushes the pages which are modified and dirty and it to the data file.
Okay, got it.
Yeah, and it also helps to recover the data. It helps to recover the data faster, right? So if there is a crash happens, let's say, for example, there is a crash happens. If there is a crash, let's say, for example, the checkpoint happens at 10:01, and the next checkpoint will be at 10:02. Let's say every 1 minute the checkpoint happens. Let's say 10:01, my transaction completed, right? My transaction 10:01 05 seconds, my transaction got completed, and I have not flushed my 10,000 pages or my pages which are modified for 2 hours or 3 hours during so the bulk operation, or during so some DML operation. Let's say assume 10:03, 10:01, 30 seconds, there is a crash. The database crashed, or so the shutdown server was shut down, server got shut down, whatever happened, what will happen to all the pages which are modified and committed, which are there in the data file, which are there in the memory, but not in the data cache, not in the data file, sorry. So if you wait for the transaction to commit with respect to whether the checkpoint interval, if you wait transaction to commit, after commit, if the checkpoint has not happened, then whatever pages which are there in the memory, which are committed, all gone. So there is of no use. So to avoid that loss, we periodically move the pages from the data cache to the data file by checkpoint, so that whenever recovery requires, then it will go ahead and recover the transactions, roll back the transactions that we have.
Checkpoint will happen transaction log file, right?
Checkpoint will happen transaction log. What do you mean?
I'm saying transaction log, right? This.
No, checkpoint, it checks if the pages are available in the memory, which are dirty, and it will be moved to the data file.
Okay.
So you will have the checkpoint information stored in the transaction log file, but it is not actually performing anything huge in the transaction log file. So it will be on the data file, data cache. It checks if the pages are available and modified, and it will write into the data file. Okay, so I think it is late.
Sorry,
Yeah.
let me ask you a question before you go. So if the transaction has been committed by the checkpoint, so that transaction goes straight to the data file, right?
Transaction right into the data file? No. So transaction will not into the right into the data file, right? So the transaction, whatever we performed and it is written to the database, that only will be written to the data file. So transaction information will be stored in the transaction log file. So whatever modification we perform written to the transaction log file, that information will be written to the data file, stating that the transaction, so modify these pages and these modifications and all. It will not write anything to the data file.
No, that was not my question. My question is, now let's say checkpoint is performing every minute, right?
Correct.
Okay, so now immediately the checkpoint has been committed. So where that checkpoint is taking the data to, is it taking it to data file or log file, or is it going to record the log file as well?
Checkpoint. So checkpoint, it will be written whatever pages which are there in the memory, which are dirty, that is modified, and it will be written to the data file.
Okay. So with that transaction commit on transaction log as well?
That this checkpoint information will be written to the transaction log file. That's it. So checkpoint will not commit anything. This checkpoint LSN, it will be written to the transaction log file, so that it will understand when the last checkpoint happens, and from there it will try to recover the data.
So
recovery.
That means all the data that go to the data page is already been committed on the transaction log.
No,
right?
No, not really, right? So the transaction commit, what do you mean by commit?
Like, this data dirty page you're talking about. So that means the data that is in dirty page is already in transaction log before you go to the dirty page.
Correct.
Right?
Correct.
So now when the checkpoint commit, it will not go to the data file.
It will not go to the data file. No, I didn't understand. See, maybe I'll repeat the same thing. So
Okay,
whenever you no, let me.
So my question is, initially, one transaction is happening, it go to a record on the log transaction log first. Then now, from that transaction log, we have a dirty page, right?
Correct.
So when the checkpoint is issued, then that checkpoint will take all the data in this data page, go to the data file, right?
Correct.
So my question now is, all that transaction that happen that make us to have a data page, are we going to see that transaction on the transaction log?
Mhm.
Do you get
So-
my question?
Not really. Sorry for that. See, okay, let me clarify that, right? So let's say you are doing anything, so it will write into the transaction log file first, then the
Yes.
modifications with the transaction information will be written to the data cache, which is there in the memory, right?
Okay.
So it marked as dirty, right? So this will have the transaction information. This will have that, so dirty page. Now checkpoint happens at every 1 minute. So if the checkpoint happens, whatever dirty page, which is marked as dirty, it will be flushed to the data file. That is your disk. Flushing is nothing but it will copy this page. In a simple word, it will copy this page and paste it here in the data file. That's it. So it will not remove this page.
That's what I'm asking. So that means it will take all the data that is in the data cache and put it in the log file, in the data file. Is this data file, the data cache will be empty after the commit of the checkpoint, or it will still be there?
That's what I was saying, right? Like the page will be copied. Copy is nothing but the page is still available in the data cache, and you will copy that page into the data file. So you are not removing the page. So it is marked as clean, and it will be available in the same data cache. So whenever you are modifying anything within the same page, it no need to scan again from the data file and put it back to the data cache. So it will be marked within the data cache on the same page, and during next checkpoint the copy would happen. From here it will be sent it to the data file. So the page still be available until some memory pressure, and you see lazy writer. So lazy writer will clean up the memory data cache, but not the checkpoint. The page still be available in the data cache. It no need to go back to the data file and scan again and keep it in the data cache.
Okay.
Is that your question?
Thank you.
Cool. So any other questions?
I have a follow-up question to that. So whatever that copy page that's going from the dirty page, which is the copy of the dirty page going to the data file. So that page can include both committed and uncommitted transactions?
Yes.
Okay.
Both. So only thing that you notice, if the transaction is not committed, the log file will not be truncated. That is a different story. But other than that, if the transaction is not committed, your data pages will be moved from the data cache to the data file. Moved as in, again, like it is just a flushing copy of the page and keep it in the data file, and the same copy will be available in the memory as well, so that whenever you do any modifications to the same page, it no need to scan again the disk to get the page. So you will have the pages available already in the memory, so it will perform some operations.
Right.
So let's say something happened to that server now, or to that instance, and there is some still uncommitted transaction in this data cache. Is it possible to back up that data cache?
Data cache backup. What you are asking? Back?
Just to get the inactive portion of this data.
Okay.
If something happened to this server now,
okay,
is there a way to get the inactive portion of this data cache?
So inactive portion of
if the checkpoint has not been issued.
Okay, so checkpoint has not been issued, and you want to see the inactive portion of the so the data cache.
Yes.
No, so inactive portion of the data cache that you cannot check.
So there is nothing you can do about it, because the checkpoint has not been committed to take the transaction to the data file, and something happened to that server. So there is no way you can do the backup of that your data cache to get the inactive portion of your data?
No, so see, so if the page is moved to the data file and the transaction, let's say transaction is still open, it is not committed, and you will have this transaction constructed information, right? So you will have the transaction ID and you will have that, so whatever LSN information and whatever checkpoint details, everything you will have. And if the page is available and marked as dirty and it will be moved to the data file, let's say the page is marked and moved to the data file, and if the transaction has to roll back, let's say for example the crash happened, the SQL restarted, everything happened, if the transaction has to roll back, then it will be scanning through the transaction log file and identify what is my last checkpoint information. From there it will try to recover the transaction. It will try to so recover the data or database by performing recovery process, right? So the dirty page you are talking, like, so whatever dirty pages, that will be, if the checkpoint has not happened, whatever dirty pages that we have in the memory, that will be gone.
Okay.
Yeah, that is in the memory, right? If you restart, if the checkpoint has not happened, then those pages will be removed from the memory. That's what earlier I was giving explanation example, right? 10,000 pages, and if the checkpoint has not happened, if the transaction has committed, so then even if the transaction is committed, if the pages are not available in the data file, those are gone, right? Those are no use, the data loss. So that is the reason we periodically checks and run that, checks and flushes the pages from the data cache to the data file. So we have a internal, some other checkpoint, checkpoint models, like, so we have that indirect, we have some other automatic checkpoint where we have to configure that periodically. It will not even wait for 1 minute. It periodically checks the threshold and it will flush it to the data cache with respect to the transaction is committed or uncommitted.
I have a actually follow-up question now. So what is the criteria for checkpoint to flash committed or uncommitted data to the data file?
So
because my understanding before, the job of the checkpoint was to determine if data is committed or not. If it's committed, it flashes to the data file. That was my understanding. So that's why I'm struggling to understand this whole thing, because now you're telling me a different thing. So what is the criteria for the checkpoint to decide if it should push data from the dirty page to the data file?
There is no algorithm or mechanism, right? Like checkpoint, it checks if there is any, it scans to the data cache first thing, and it understand if there is any so pages which are marked as dirty. So if the pages are marked as dirty with respect to, so whatever algorithm that we have, so it flushes all the pages in a scatter, like, so it will just gather and, so it will flushes to the data file. So it doesn't even evaluate any of the calculations. It checks whatever pages which we have on the memory, which are dirty at the time of checkpoint. So it will flush everything and mark as clean.
So anything that's labeled dirty will go from the data cache to the data file.
Correct.
Okay.
It will have a bit, right? So in the each page, it will have a bit that whether it is a dirty or clean, like 1 or 0, some bits you will have that. If it is dirty or clean, it will identify, and based on that, it will just go ahead and so flush all the dirty pages to the disk. It's a just so scatter way, like, so it doesn't even construct a serial way to, so write into the data file. Just scatter and, so it will write into the data file, and that will so the so it will write into the data file whatever pages which we have.
So what's considered clean page?
Yes, so after this write into the transaction data file, it will be considered as a clean page.
Okay.
Yeah, until and unless the same page is modified again. Yeah,
Got it. Okay, thank you.
Yeah, yeah, I have one question.
Mhm.
Yeah, is it possible to identify when the database was like modified time? Is it possible? Yeah,
Database
exactly.
page modified time.
Yeah,
Why that is required? I mean, so I never tried, but I don't think that. So page modified, maybe you, I mean, to answer your question, so we have some other way we can use some trace flags to dump the page and, so
yeah, I
see
know.
when the DBCC, sorry.
Yeah, 3601 trace flag, but without trace flag, is it possible or?
But why that is needed? That's what my question, like why it is required you
Yeah,
to.
actually, I have one activity in our company. Uh, when the table was exactly modified or not.
Table modified is different thing and page modified is different thing, right? The table
Yeah,
modified. So if you want to capture the table modified, maybe you will have to capture some auditing traces and all and to get the table modified. But it is not recommended to use any DBCC page DBCC page and to dump the page into the, so to read the page, right? So that is not recommended. But if you want to check that table modification history or details, maybe you'll have to have some other tracing mechanism to check that, right? Either table level audit or, so that audit you will have to configure.
Yeah, actually, I don't have any table level auditing, so
Mm.
that's why I'm asking. If once the page modified time is I identified, it is possible to the when the table was exact time
I don't think that table
modified.
exact modified, maybe you can check that, like if you have any column data, right? So if you have any modified column, definitely table should have modified column, right? If you have that, maybe you'll have to check that when the table was modified. So otherwise, table modified date, right? Suppose if you have any DML operations which are there, like you will have to check that. Otherwise, so I don't think that you will have. Maybe you can check the DBCC IND, so that you will see that page information.
Yeah,
Even I am doubt that you will have the time even with the DBCC int command.
yeah, I tried so many times, but I don't
That
get.
that that is not so straightforward, right? That there is no way that you can identify modification date by using the pages. You will have to check some other way. And if you have a date modified column, and you will have to check the date modified column.
Okay, okay, thank you.
Yeah. Sorry to stop you here. Like any questions, because I know US people, like, so it's very late to you guys. Like if you have any questions, we can talk. Otherwise, we'll disconnect today and we'll connect tomorrow.
Yeah, hi, this is Anil. No, actually, you have said like after checkpoint, the page will clean, right? Clean means it not removed from the buffer pool, right?
It will not be removed from the buffer pool. It will just,
Yeah,
so
once
keep
it
that
got,
page in the memory.
yeah. Once it will checkpoint completed, it will move to disk and the page in the buffer pool, the page will move to free buffer pool list, right? Free list.
So no, not free list. What do you mean by free list?
No, free list means it will after the for example,
Page is
if it
still no, not in the free list. So free list is for, let's say for example, if the page is it is moved to the clean buffer list, right? So if the if the page is clean, so it will still be available in the memory, the buffer pool, and it will be available for any modification that we use.
yeah, correct only. But when it got removed from the buffer pool.
So by
Lazy
checkpoint,
writer.
by lazy writer, yes.
Lazy writer will clean
Yes.
method.
Yeah.
Yeah, lazy later. On which basis it will be removed?
That we will talk. Lazy
Yeah.
writer based on the LRU algorithm, the least recently used algorithm. Based on that, it will be removed if there is a memory pressure or any memory issues on the server or the database.
Yes, that's correct. But in LRU algorithm, to identify that one, it is to get the data right from the free list only. What I read from this one, like from the free list, the LRU algorithm will use least recent used algorithm.
Okay, so we'll talk that later.
Yeah, sure. Yeah, can you please share your mobile number so I will check with you once again? Actually, you have pasted this one in the group, right? So it will be removed, I think.
Which one you'll have to you need? Which one you need?
Sorry.
No, so I'll ask Shanmugh to share that info.
Yeah, but actually that is already removed, I think.
No, what is removed? I don't know.
No, that meeting details will be there, right? That meeting details will be removed from that group. So can you please share your someone contact number so I will contact
Sure. I will share that
in the chat.
second. Yeah, I'll share that.